Okay, here's part 2, starting from page 8. Here's another example that takes polynomials of degree 2 to polynomials of degree 2 with the rules given. Of course, this is enough to know, and they want you to write the general rule. Why this is enough? Because, as you could see, we have t of 1, t of x squared. And notice that the basis for polynomials of degree 2, the best one, the most natural one, consists of 1, x, and x to the second. So you have everything you want. So let's get started. What is t of polynomial of second degree? Well, that's going to end up t of the form a sub 0 plus a sub 1 x plus a sub 2 x to the second. Applying the theorem that talks about both properties in one, we're gonna go t of a sub 0 plus t of a sub 1x, but I'm gonna pull the a1 out. That's why I say it's 2 in 1. T of x plus t of a2x to the second, which is the same as a2t x to the second. But as we said earlier, you have t of x and you have t of x to the second. T of 1 is not clear yet, but we could take a sub 0 from here out and leave it as t of 1. So let me show you this part. T of 1 and a sub 0 is outside. Applying rule number 2, which is a scalar times 1 inside, you take the scalar outside, and that's my a sub 0 plus a sub 1 t of x plus a sub 2 t of x to the second. You have this up defined, and this one up defined, and this one up defined, and we're almost ready. That's going to be a sub 0 times what is t sub 1. Up here it says 2 minus 3x. A sub 1 multiplied by t of x, which is up here, and that is 2x plus 5x to the second, and a sub 2 multiplied by t of x to the second, defined as 3 minus x plus x to the second. Multiplying and combining, you need to show that this is in P2 in the codomain. At this point you might feel like you're ready and you're done, but that's not done. I need to see it in the form of a second degree. What's a constant term, what's a first degree term, and what's the second degree term. So here's my constant after I rearrange. A2 a sub 0 plus 3 a sub 2. That's my constant. I'm gonna go down and tell you that now we're moving to the first degree constant, and the first degree constant will be first degree term will be negative 3a sub 0 plus 2a sub 1 minus a sub 2 multiplied by x. That's my first degree term, just by combining wherever you see the x's. What do I mean by this? You look for the x term, the x term, the x term after you multiply by a sub 0, a sub 1, and a sub 2 and combine them together. The third term is plus, and I have the second degree term, which is 5 a sub 1 plus a sub 2 x to the second, and that is in P2, and that should do it. Page number 9. Page number 9 has a theorem that says if you have a transformation from R n to R m, and notice that they mentioned a matrix now right here of real numbers. This A is a matrix of size m by n. Something that you need to pay attention to, which is the following. If you notice here, we're going from Rn to Rm, and the matrices start with m rows. So n to m, the matrix will be m by n. Kind of like you switch the letters right here. Something that you need to pay attention to. What this says, that you could look at your transformation being defined this way. That t of x, well, x of course in my domain, which is Rn, will give you ax, and a times x, a matrix multiplied by x, will be actually in Rm. Keep that in mind. We have this transformation. Before I move on, as you can see it's written, but I'll clear it up for you. This transformation from Rn to Rm, defined by t of x equals a x, is called a matrix transformation. Then I went off here, so let's rewrite it. A matrix transformation. Alright. What this says, if you have x and y in R to the n, and c is a scalar since we are in the real numbers, this is a linear transformation. So both properties do hold. T of x plus y will equal to A, the matrix A, multiplied by x plus y, which is A times x plus b times y, which is tx plus ty. The second property says if you have a scalar multiplied by the matrix A, take it back. Scalar multiplied by an input, which is a matrix. One more time. It's x, but it's not a matrix. It's x such that x is actually in R to the n. That will end up a matrix A multiplied by your input, which is a scalar multiplied by x, which is going to end up C A x, and that is C, the output T of x. Now here's a practical example. About how the transformation works in matrices. In this case, we are going from R to the second to R to the 4. And notice that the matrix is 4 rows and 2 columns. Something that you need to keep that in mind. Next, I want you to notice the following, that you are going from inputs of this look, because you are in R to the second, and you're gonna go to outputs of 4 parts in it, because you are in R to the 4. That helps a lot to stay focused. So to write the general rule, which is hard to just keep looking at the matrix and not knowing what to do, this is an example as a discussion. Not much actually, but they want you to write the transformation as AX. But how do you write AX? And how do you write the output in general, or the general rule? So we have an input in R to the second. I'm gonna call it X1, X2. That is in R to the second. Since the output is gonna be 4 places, I'm gonna make the 4 places and come back and write them down. And just pay attention how I'm gonna write the 4 parts. The first part is 2x1 plus x2. Now take a look and see, where do I get those from? If you notice that I took it from here. Okay, now second one, what do you think the second part will be? Alright, that's a 3 x1 minus x2. I know it's something new, but if you see it and you practice, it's not hard at all. It's just like another language or another way to read things and write things. Third part will be minus 5x1 plus 3x2. And the last one will be just minus 4x2. This is a general rule. I want to add to it, how would you write it in general as AX? Take a look at this. I have T of X is defined to be as AX. So it's a matrix A of size 4 by 2 times an input X that belongs to R to the second. Okay, here we go. This is my matrix. Which you know what I'm looking at. It's 2, 1, 3, negative 1, negative 5, 3, 0, negative 4. And this is a 4 by 2. My variables, or my input X as the unknown matrix, is gonna start with 2 rows, and knowing that, I'm gonna write my X as 2 by 1, which is X1 and X2. If you multiply these two matrices, we do have the condition available, and we're going to end up with an output that is a 4 by 1. So let's make a 4 by 1. Here's a 4 by 1. Now pay attention that to the first row. The first row will be 2x1 plus x2, just by multiplying row 1 times column 1. Yeah, but if you notice that this is the same thing as this. So that's your first part of R to the 4 elements, which is right there. What's the second part? Second part is going to be 3x1 minus x2, and the third row will be minus 5x1 plus 3x2, and the last part will be 0x1 minus 4x2, which is a 4 by 1. 4 by 1. 4 parts. As you saw above, we have 4 outputs or 4 elements with commas that belongs to R to the 4. So we are in R to the 4. Okay. Moving on to the last 2 pages. This right here, determine the matrix of the linear transformation R to the 3rd to R to the 4. Yeah, I have given the definition defined this way. They want the matrix. Probably from the previous example you could write it down quick, but let's just discuss it quickly. So we have T of x1, x2, x3 equals. Notice I have 4 spots. Here's my first comma. Here's my second comma. Here's my third one. I do have 4 spots. 1, 2, 3, 4. Now let's go back and pay attention to my transformation defined from R to the N to R to the M. This is what we have. So what do you think the matrix that we are asked to write down has a size of what? It's actually going to be a 4 by 3. And let's see if we could write it together. Equal. I have a matrix of 4 by 3. 1, 2, 3, 4. I do have 4 rows, planning, and 3 columns. We call it 4 by 3. I'll write the first one, and hopefully I'll slow down so you can see how we could follow me writing the second one. So I'm going to write -1. I'm going to write 0. I'm going to write 3. Okay, try to see where I got this from. Okay, let's keep going. Second one, that's going to be 0, 0, -2. Third one, 2, 5, -9. Third one, -7, 5, and 0. Now you have it. You have 4 rows and 3 columns. And if you could test it, multiply it by the matrix x1, x2, x3. If you do that, x1, x2, x3, you should end up with a 4 by 3, which is written on top. Okay, now last page. Here's something different. We're going from r to the third, r to the third to r to the second. But if they give you what's the output for 1, 0, 0, and they give you the output for 0, 1, 0, and they give you the output for 0, 0, 1, you could write pretty much anything, because that's the basis in r to the third. They gave me the first one right here. They gave me the second one right here, but they didn't give me the third one. Instead of the third one, they gave me something different. They told me that 2, 1, negative 3 is mapped to 7 and negative 1, which is at the end. So what we need to do is we need to write or find out the output for this right here. To do that, we need to write 0, 0, 1 as a linear combination of the ones that are given to me, which is 1, 0, 0 plus C2 0, 1, 0 plus C3 times 2, 1, negative 3. With algebra, solving for C1, C2, C3 using matrices, using linear combination, we end up with the following. That C1 is 2/3, C2 is 1/3, and C3 is negative 1/3. Meaning 0, 0, 1 is 2/3, 1, 0, 0, and we have 1/3 here, 0, 1, 0, and we have minus 1/3, 2, 1, negative 3. Of course, you can test it and see if that is true. Now, here's an interesting part. They missed this for me. They missed it. They didn't give it to me. Now we're gonna find it. What's t of 0, 0, 1 is? It's gonna be applying the transformation or the mapping to this. That means I need to apply it to the right hand side. Now applying to the right hand side, because this is a linear transformation, I could use the theorem. I could apply the two properties. So I do have 2/3. Instead of saying that transformation of 2/3, 1, 0, 0, we pull the 2/3 out as a common factor or as a scalar, applying rule number 2. So that's going to be t 1, 0, 0 plus, same thing, 1/3 t 0, 1, 0 minus 1/3 t 2, 1, negative 3. And we do have those on top given to me in the problem. So what's t 1, 0, 0? It says on top 4 and 5. So I'm going to write 4 and 5. And 1/3 t t of 0, 1, 0, it's on top as negative 1, 1, negative 1/3. What is t 2, 1, negative 3? It was 7 and negative 1. Apply the 2/3 in, the 1/3 in, negative 1/3 in, and add the components. I end up with 0, 4. So now we have it. We do have what was missing. Meaning, we have 1, 0, 0. It's taking me to 4, 5. We have 0, 1, 0. It's taking me to negative 1, 1. We have 2, 1, negative 3. It's taking me to 7 and negative 1. I was looking at the problem. Up. Now we have what we found and what was missing. 0, 0, 1 is taking me to, yes, 0, 4. Which is right here next to me. Now, let's see if you could write the matrix. Well, we know that we were going from R to the third to R to the second. So my matrix is actually 2 by 3. 2 rows, 3 columns. See if you could write this as 2 rows and 3 columns, just by looking at the left. Okay, here's one way to do it. I'm gonna write 4, 5. I'm gonna go with columns now. Just pay attention and see if you could see it, so you could follow me with the second ones. Okay, that's right there, and that's right there. Moving on, just keep it in columns now. We don't want to switch back and forth. You can if you want. Here's negative 1, negative 1, and 1. And of course the last one is 0 and 4. So what's the general rule? If you go up in the problem, or if you have your book hand, I don't want to go up and down, it says what is t of x1, x2, x3. That was the question. We want the general rule. Because that's going to equal to a times x, which is a, we just wrote that, 4, 5, negative 1, 1, 0, 4, times x. You know what's x? I already have it right there. That's my x, which is x1, x2, x3. Let's double check to see if everything is fine. Yes, we do have a 3, a 2 by 3. We have a 3 by 1, so we're going to end up with a 2 by 1. Instead of writing it as a matrix, I want to tell you that I want to focus on this. This is my output, r to the second. So I should be in r to the second. You could write it as 2 by 1 as a matrix. That's a 2 by 1. Or you could write it directly as a rule. So what is t x1, x2, x3? Just by multiplying these two matrices, you can find exactly what you want. You want to be in r to the second. So let's write them down. What's the first piece? Row 1 times column 1 and that's 4 x1 minus x2, and row 2 times column 1 will give me 5 x1 plus x2 plus 4 x3. And now that should be the end of it. Hopefully that was helpful. Sorry for the audio. I noticed that in the first video that I deleted, but I don't have an external microphone, and every time I move my hand while I'm writing, it picks up. The microphone is right next to my hand. It's on the tablet, not outside standing up on the desk. One more time, hopefully this will help you. If you have any questions, I'll see you in class, and I'll be ready to answer any questions that you need. Thank you, and I'll see you in class.